Alright, so this next objective is to identify asymmetric centers. And I've built a couple more models for that. So the question is, if we have, if we've got two carbons, okay, can you see I've got a carbon here, let this be a carbon, and each of these be separate substituents where the blues are the same, okay? So I've got 1, 2 blue, 1 red, 1 gray, same for both of them, okay? Methane, I guess, okay? Look at those, and can you see that they are mirror images of each other? Alright, can you see that from the picture? You can't, can you? So it's not moved over too far, okay? These are mirror images of each other. Alright? So the question is, are they the same thing or are they not? And of course they look like the same thing because they're mirror images of each other, but in order to find if they're the same thing or not, I've got to turn them around and superimpose them on top of each other. So if I turn that around, it looks like the red and the gray are no longer the same. But you know what? I can turn that over and say, oh yeah, look at those molecules line up exactly. Okay, so these in fact are the same thing. They're identical. So these are not asymmetric centers. The question is it asymmetric center? We have to identify asymmetric centers, and they are not. All right. Which I realize I never defined an asymmetric center for you, but all right. Now look at these. These are. Can you see that these are mirror images of each other? All right. Look at that. Those are mirror images of each other. And if I were to say, are they the same thing? Is there an asymmetric center here? My guess is you would say, no, they're the same thing. Okay? That certainly was my guess when I first did this. They look identical. However, if I turn them over and try to superimpose them on top of each other, then they cannot be superimposed. They do have different absolute orientations. So when I do that, I go, oh, well, the blacks and the blues are all lined up, but the red and yellow aren't. And my first thought when I saw this was, oh, no big deal. I just turn those over and they'll be lined up. Okay? No big deal. All right, so wait, okay. So now these are lined up, but the blacks and blues are not lined up. So let's take the blacks and blues, see if we can turn those over and line them up. And I think you can see the problem I have here, that no matter what I do, I won't be able to line those up. The real reason for this is sort of a math question that has to do, I don't know, with topologies, or I feel silly as a mathematician going to watch this and it's going to be really obvious, but it has to do with the fact that that real shapes are defined by 4 dimensions. I mean 3 dimensions, okay? 4 points. 4 points define a real shape. And again, please pardon me, mathematicians, if I'm using terminology which is silly, but what I'm going to do is come to a very quick conclusion here that I can identify an asymmetric center if I can simply see a carbon with 4 different things on it, A, B, D, and E. If these are 4 unique things, circle and, I don't know, crescent, okay? 4 unique things coming off of a central carbon, then it is asymmetric. Okay? Now let me leave you with a quiz question. 1, 2, 3, 4, 5. Is this an asymmetric center? That's the question. Is that asymmetric? Okay? And let's go on to the final objective. And actually, we need a separate video for this. This is just going to be long. So I'm sorry for the 3 videos here for lesson 9, but it's going to take it. It's going to require it. Thank you.